Today we're going to be learning lesson 3-2 in your textbook, which is titled Graph Linear Equations, which is what we're going to be doing. So to begin, an example of an equation with two variables could be this: 2x plus 5y is equal to 8. This is just an example. So no longer do we have equations just with an x, but now there might be an x and a y. And when you have an equation with two variables, that means that you're no longer just going to find one solution, right? You're going to be able to find many solutions, and all of your solutions will be in the form x comma y. So you'll find a coordinate. So for example, the coordinate 4, 0 is a solution. The reason why is because when I plug it in, we're going to find that 2 times 4 plus 5 times 0 is really 8 plus 0, which is 8, which is what I have on the other side. Also, let's see here. How about -1, 2? Is that a solution? Well, it actually is. It is a solution, because when I plug this in, I'm going to get 2 times -1 plus 5 times 2, which is the same as -2 plus 10. And that also is 8. Let's do one more. 3, 2. This one you're going to find is not a solution. Not a solution. And the reason is when I plug it in, again, 2 times 3 plus 5 times 2 is the same as 6 plus 10, which equals 16. But that is not the same as 8, so it is not a solution. So you're going to be able to find multiple coordinates that are solutions, but you also need to be able to figure out, hey, I have this coordinate, is it a solution for my equation? And be able to figure out why that is or is not true. So graphing these type of solutions, you're going to have a coordinate plane, okay? The first thing that you want to do when you're given an equation, like this one says -2x plus y is equal to 3, is you want to rewrite it so that it says y is equal to everything else. So to do that, I'm going to add 2x to both sides. And now I have it rewritten, y is equal to 2x minus 3. This is going to be so much easier for you to do, to graph your equation. So then we're going to make a t-chart to find out all different points that are going to be on this graph. And you get to pick any numbers that you want if it doesn't specify. And it doesn't. So I'm going to just pick some of the most basic numbers. I always want you in the beginning to start by picking 5 numbers. So I'm going to pick -2, -1, 0, 1, and 2 for my x values. That's going to be my input. And let's plug them in. When I plug -2 into my equation, I get -4 minus 3, which is -7. When I plug in -1, I get -2 minus 3, which is -5. When I plug in 0, I get 0 minus 3, that's -3. Plug in 1, that's 2 minus 3, which is -1. And plug in 2, that's 4 minus 3, which is +1. So I've done that. That's my second step. My third step is just graphing those dots. So I have -2 down to -7, -1 down to -5, 0 down to 3, 1 down to -1, and 2 up to +1. I'm just doing 5 just to make sure that I am on the right track. When you're done, we are going to connect all the dots with our ruler and draw an arrow going in both directions, because this graph means that all of these points, and there's so many more, are solutions for this equation going in both opposite directions. Okay? So this is the premise for today, and it's probably stuff that you've done before. So, a linear equation is an equation whose graph is a line. That's really important. You're going to see this term linear equation over and over and over again, and what it's looking for is a line. That's what the graph is going to be looking for, and it's in its name, linear. Okay. Equations can be written in different forms. We're going to, in this lesson, be talking about the standard form of a linear equation. And it's just rearranging the equation so that it looks like some number, a, times the variable x, plus some other number, b, times the variable y, is equal to some other number, c. Okay, so a, b, and c are real numbers. And the only other thing is that both a and b can't be 0. One of them could be 0, but not both of them. That would not be an equation that we're able to put in standard form. So I have an example here, and it looks very basic. It says graph y equal to 2. So for this one, what I want you to do is, again, just pick some points to start out with. Pretty soon you're going to be able to graph this without picking any points. So I'm making my t-table, right? And I'm going to pick some values for x. So let's say -2, -1, 0, 1, and 2. Well, when you look, I don't have an x in my equation to plug it into. That is because really what this looks like is it looks like 0 times x plus y is equal to 2. If that were the case, if there was the number 0 times x, then it would just be invisible, and it would just be y is equal to 2. So when I plug in -2 times 0, that just cancels out still, and y is still equal to 2. Same with -1. 0 times -1 is 0. Y is equal to 2. 0 times 0, y is equal to 2. 0 times 1, y is equal to 2. 0 times 2, y is equal to 2, and so on. I think you get the picture. So if I was going to graph all these points, I'd have -2 up 2, -1 up 2, 0 up 2, 1 up 2, 2 up 2. And the line that I have is a horizontal line crossing the y-axis at 2. Okay, pretty cool. Here's another one. This time I want you to graph y is equal to -1. So this time I have my x and I have my y, and I'm actually told in the beginning what x is going to equal, -1. Okay, so it doesn't look like I can really choose any other values for x. So what this equation really looks like is x plus 0 times y is equal to -1. Because 0 times y is just 0, and then you have x equals -1, which is my beginning formula. So it really doesn't matter what number I plug in for y, x is still going to equal -1. So I could have -1, 15, I could have -1, 2, I could have -1, 4, I could have -1, 0. Whatever it is, the y value doesn't matter because x is still going to be -1. So let's just plot these points. -1 up 2, -1 up 4, -1, 0, -1, -1. And this time what we see is that these dots are forming a vertical line where it is crossing the x-axis at -1. So from these examples, what can we learn? When I have an equation that says y is equal to a number, what does that look like? Well, what it means is that it's going to be a horizontal line, and it's crossing the y-axis at whatever that number is. If it's y is equal to -2, it would cross down below at -2, but it's always going to be a horizontal line. Whereas if you have x is equal to a number, it's going to be a vertical line, crossing at whatever that number is on the x-axis. Okay, so let's remember this. Y is always going to be horizontal, and x is always going to be vertical. Very rare instances will you see these equations, but you'll know exactly what to do. So we're going to do one final example. This one says to graph the function y is equal to -1/2 x plus 4, and this time the domain is very specific. Any x value as long as it is greater than or equal to 0. So we want to graph this function with this specific domain, and then at the very end we want to identify the range. So let's do like we've done before. Looks like the equation is already written, so it says y is equal to everything else. So I want to pick my x values, but I can only pick the numbers where x is greater than or equal to 0. So let's just start with 0, and I'm just going to pick some small ones, 1, 2, 3, and maybe 4. Okay, and let's plug them in. When I plug in 0 to my function, I get y is equal to 4. When I plug in 1, this becomes -1/2. What is 4 plus -1/2? Well, that's 3.5. I'm just going to put the decimal form. When I plug in 2, 2 times -1/2 is -1. And -1 plus 4 is +3. Plug in 3 times -1/2, that's -1.5. Plus +4 is 2.5. And lastly, let's plug in 4. 4 times -1/2 is -2. Plus +4 is +2. So I have my values. Let's go ahead and plot them on the graph. 0 up to 4, 1 up to 3.5, 2 up to 3, 3 up to 2.5, and 4 up to 2. Okay. The very last thing that you need to think about, though, is how you're going to draw your line. I'm not going to draw a line that continues forever. I'm only going to draw a line where the x's start at 0 and keep getting bigger. So it's only going to have an arrow going in one direction. This is a ray. And that's because I'm only showing those x values bigger than 0. So then I have my graph. The last part is I need to identify the range. And I'm not going to just copy down these numbers that I have listed for y, because the range means for this function all the different possible values for y. So how could you describe the values for y? Well, let's look at where we're starting at. I'm starting where y is equal to 4. And every time what is happening to the y values, they're getting smaller and smaller and smaller. So the range is going to be all of those values of y as long as they are less than or equal to 4. And I'm done. Okay, so I have one problem for you at the very end. I want you to try this one on your own. There we go. Graph the function y is equal to -3x plus 1. This time the domain is all numbers x that are less than or equal to 0. So choose your specific x values, plug them in, graph your function, and then at the end identify the very specific range. And come to class with any questions you might have.